What is orchestration? What is choreography? And why should we care about these when deciding on software architecture? Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I have a quick, brief explanation of orchestration, choreography, and orchestration versus choreography. Which means we're gonna look at a few things. We're gonna look at what orchestration is, we'll look at what choreography is, we'll look at a few examples, and then we will discuss about the trade-offs of each approach, because as usual in software architecture, nothing is perfect, everything has trade-offs, so you need to think in terms of these trade-offs. And let's start by looking at what orchestration and choreography is. And there are a few, there is a way to remember this easily. I used to be very confused about these terms. I heard people talking about those and it was pretty confusing. What are we talking about? Orchestras, dance, what is this about? First, this choice is often in the context of distributed architecture. So you have a few different services or APIs, or can be external tools or legacy tools. But anyway, you have a workflow. You have a set of things that you need to do in order for a feature to work. And those things are not part of one monolith, but you have to do them as calling other things, whether they are from your own organization or outside your organization, it doesn't really matter. And the question is, how do you manage to implement this in a distributed system? And you have one choice, one important choice. Other choices follow, but this is one important choice. Do you use orchestration or choreography? And let me go into explaining what these things are. So orchestration, imagine you have an orchestra and you have people playing various instruments. Somebody needs to direct that orchestra. So you have the role of a director. In our metaphor, each service is one player who plays at an instrument, and you have the director that directs. Now you are playing, now you are playing, now you are playing. Basically what this means is that you have some kind of central coordination. You have one service, API, monolith, web app, it doesn't matter, but you have one deployable entity that calls the other ones and says, okay, so now you do that, you do that, you do that. This means that the orchestrator or the central coordinator or the director knows precisely the workflow. So this is where the workflow resides. And he knows to say, you do that, you do that. If things go correctly, he knows how to finish the workflow. If something happens and there's an error, he knows how to finish the process within the failure states. And when I say process, let's say finish the workflow. It's a business process. Finish the business process. What is choreography? Well, if you look at ballet, what you see is that people are dancing and nobody is directing them. They know their moves. Each of them knows their moves. They occasionally come together. They occasionally dance separately. So it's more about each entity, and once again, switching metaphors to our distributed system, each service knows what it needs to do, and there's an emergent behavior that solves the whole process. And if there are error cases, there is again an emergent behavior that needs to deal with that. So now this means it's more like a distributed coordination. So you can have a central coordination, the director, or orchestration. You can have distributed coordination, choreography, and in this case, the case of choreography, there is no central decision maker, and services just know how to react. Now, this matters because it leads to a few consequences. You have different failure modes. You have different ways of dealing with failure, because if you have the central coordinator, it knows how you will find there. You need to have there all the conditions for failure. And debugging is mostly, if you debug the workflow at a high level, you look at the central coordinator. If you debug one of the steps, you look at the separate entities. You could have different team ownership models. For orchestration, you can have teams that are distributed all over the world, and each of them just takes care of one service, because what matters is the emergent behavior of each of these all these services. But this, you get there by splitting the overall functionality into distributed behaviors. You might have different operational complexity because, of course, orchestration is easier to deploy. Well, not necessarily. I mean, deployment is kind of the same for both. You just have plus one entity, but monitoring could be more complex for choreography because you need to make sure that the requests go wherever it needs to go. And there are also potential issues with security. You need to take care of those. You might have reliability things where you need to restart services and so on. So these two are pretty different in terms of implementation. Now let's think of a very simple example. Let's say you have an e-commerce order processing, and let's discuss about the orchestration version. So you would have an order service. The order service receives a request, and then the order service starts calling. Inventory service, reserve items, waits for response. Payment service, process payment, waits for response. Shipping service, create shipment. Notification service, send confirmation. The flow is visible in the order service. If you have a choreographed version, you could either have services that call the next one. So one example here would be the initial order request goes to let's call it order initiation service, right? That creates an order, calls the inventory service calls the payment service calls the shipping service, and so on. And this is how you can have synchronous or blocking calls, step-by-step calls for a workflow. Or you could go event-driven and say order service is called, it publishes order placed, the inventory service listens to that, reserve stocks publishes inventory reserve, payment service listens to inventory reserve, processes payment, publishes payment process, shipping service listens for payment process and creates the shipment and then publishes the schedule and so on. In this particular case, and in both implementation, no service knows the full flow. They only know either what other service to call next or the event. So if you look at orchestration, you can find the workflow somewhere. And if you're using some kind of workflow notation, then you can find it perhaps even easier in one place. But if you do choreography, it's implicit. It's an emergent behavior, harder to understand. You need more documentation for that particular workflow. Now, one place where you might see that is the saga pattern. The saga pattern is a common pattern used with microservices, but not only, but particularly since a lot of people are using microservices, we'll focus on that, where you need the transactional behavior with multiple microservices. And the way you do that, you could do distributed transactions to phase commit, but that doesn't work as well. With a saga pattern, you implement basically commit and rollback methods for each microservice. So the whole transaction is basically split into smaller transactions. And in case you have the same situation like order processing that we were discussing before. Let's say you do all that, but when you go to the shipment, there actually people cannot find the product in the warehouse. And then you have an error state. And you need to go back and basically roll back the shipment, go back, roll back the payment, go back, roll back the inventory, and roll back the order. Now, I'm going to use rollback. Usually, you need to implement either rollback or a compensation mechanism. So when I say rollback, it might be that you are posting a new transaction or just changing some attributes. Or so rollback for a payment means creating a new transaction sometimes when you go, you pay the money back. Or if you just put a hold on the money temporarily because it's a credit card and you can release that. So it depends a lot on the implementation, but I don't want to get too bogged into details. When we talk about inventory reserved, since the object was not found, the product was not found, then inventory reserve is meaningless, which probably means you just need to release the inventory on a product that doesn't exist. So, and maybe there's something to do there. And perhaps you need to notify the user. So when you go to the notification part, it needs to be some kind of notification that something has failed and so on. So if you do this with an orchestration, then what you have is a central service that would call each of these. You'll have the order service that calls each of those. If something goes wrong, it calls each of them. Say, okay, roll back, roll back, roll back, roll back. And that's basically how it works. If you do choreography, once again, you have a choice between direct calls or events. If you do direct calls, then each service will call rollback on the previous service, on the previous caller, and so on. If you have event-based, then you need to throw events saying, okay, payment failed or something failed, and all the other services need to react to those and do their own compensation or rollback. Now, this would be a very simple implementation for Saga, right? Orchestration versus choreography. And now we can discuss about the trade-offs, which is the most interesting conversation. I'm gonna go through some important non-functional requirements: scalability, performance, reliability, and security. But we can, the important part here is these are general observations. You need to decide on each of those in your own context, on a very contextual basis. So let's talk scalability. When we do orchestration, the orchestration is a potential bottleneck because it handles all coordination. So if you have multiple calls coming in, the orchestrator might not answer in time. It must scale to handle all active workflows, but the individual services can scale independently. In choreography, you have no central bottleneck. Your service scales up and down, but the event bus can become a bottleneck. And so it seems that you could use choreography to scale horizontally easier, but you need a good event bus, very reliable one, and one that scales well. If we talk about performance and latency, and once again going back to scalability, there can be other factors, right? For example, if one of the elements in your system is a legacy application that doesn't scale that well, you need to take that into account. So there is always a question of very, very contextual decisions. These are just general observations. Don't use them as such. These are just a model of how to think about these problems. Performance, and big part of performance in distributed systems, particularly microservices, is latency. If you do orchestration, you can optimize critical path, you can do parallel calls, you can do batch operations, you can implement smart timeouts, circuit breakers. This is always a good idea. But you do need additional network hop to and from orchestrator on each step. And the orchestrator processing time gets added to the critical path. So the time spent in orchestrator can actually delay the process, which means that you have additional calls. So you need to take that into account. Your orchestrator needs to be fast, as fast as you need for your context. For choreography, you have no central coordinator overhead. Services can process events naturally in parallel if you're using event-driven. If you're using direct calls, then it will be sequential. So you can also do parallel things. So maybe one service is kind of a mini orchestrator, calls the next two parallel steps. This could work as well. So yeah, you can definitely do that. But if you use events, services will just be parallelized naturally. But you have latency in event publishing and subscribing. You have event bus processing overhead. It's harder to optimize the critical path because it's an emergent property. So it's not very clear how you manage to look at the system and say, okay, where is the problem if something is too slow? So we can say that orchestration can be faster for simple flows. Choreography could be faster for complex parallel processing, but once again, general observation, this is very contextual. Reliability and failure handling. The orchestration has a single point to handle failures. If something doesn't work, the central manager will deal with that. It can implement sophisticated retry logic that is specific to your system. You can have timeout management centrally. You can have circuit breakers. It's easy to implement high availability for the orchestrator because it's contained. But you have the orchestrator as a single point of failure. If the orchestrator goes down, you need to be able to recover the state. Otherwise, you lose the business process, the work that has been done until then. If you have choreography, you don't have a single point of failure. Services can fail independently, which can or might or might not trigger a failure of the whole business process. Perhaps you can do retries and so on, and this happens in a natural way. Partial failures don't stop unrelated flows. But then you once again need to pay attention to a few implementation details. So for example, services must handle duplicate events and out of order events. If services go down and then they go up, or if the order of delivery of events is not guaranteed in your event bus, then you need to compensate that in your services. Events might come in the wrong order, and you need to figure out how to do that. Or duplicated events might come up, because imagine you send an event, but the service stops, and then it restarts, and then it emits again the same event. So you have twice the same event, but at different points in time because of failure states. Compensation logic is distributed, so it's harder to verify correctness. If you're using a saga pattern, it deals with the business process issues and transactional behavior, but it doesn't deal with the error states that are very technical. So orchestration seems better for predictable failure handling, but choreography for isolating faults, which means if something goes down, at least there's only one thing that goes down if it doesn't go all down. because you don't have a single point of failure. Now, of course, you could compensate and say we can use orchestration, but we'll always have two services started and we'll have them synchronized somehow so they can take work from one another if things, but all of these things are in addition to what you're doing. So be very careful because each of these has a trade-off. There's no perfect solution. Now, if we talk about observability and debugging, in orchestration, you have a complete transaction view. It's easy to trace. You have a single place to add monitoring and metrics. You can answer pretty easily where did this transaction fail. You can visualize the state machine. But with choreography, you have transaction states scattered across multiple services. You need to have correlation IDs for events, if you're using events. You need distributed tracing. It's harder to answer what happened to a specific order, and you need a way to do distributed logging that allows you to reconstruct flow from event log. So this seems easier, but remember that you have increased coupling with orchestration, so changeability is not that easy. If you only take into account observability and debugging, yeah, but it's hardly the only thing, the only factor. For operational complexity, if you're doing orchestration, easier to test, easier to debug, simpler mental model, fewer infrastructure pieces because you don't have an event bus. Well, you might not have an event bus also with choreography, but often with choreography you will have events. Teams can understand flow by reading orchestrator code. If you're using choreography, you have this emergent behavior that's much harder to understand. There's no single place to see full workflow. You need documentation for that. But you don't have a coordination service to maintain, and services are more independent, which means higher independent deployability, which is good. So in this case, I would say orchestration tends to be better for understanding, for cognitive load, for debugging. But choreography is better for independent deployability, which can allow you to scale very quickly. So this is one of the costs you can pay with microservices. Infrastructure costs is another interesting factor. With Orchestrator, you need to pay for the orchestrator service, for the infrastructure and database and the network and so on. With choreography, you need to be careful in case the services are calling each other, you need to pay attention to how much data they are passing in and out. If you're using event bus, then you have to pay for the infrastructure for the event bus. And this can be significant at scale. So be careful if you send a lot of events and you're using a public cloud. Try to estimate your costs. Then let's talk about security. With orchestration, you have a single place where you enforce authorization, authentication. This assumes that the orchestrator, central manager, plus the services it calls are in a single security perimeter. So your single place to enforce this, orchestrator can validate entire workflow before starting. It's easier to implement OD logging, but the orchestrator needs credentials and permissions for all services. A compromised orchestrator means a compromised flow. For choreography, each service enforces its own security. We can go closer to zero trust. Limited blast radius, if one service is compromised, tends to be limited. But it's harder to enforce end-to-end authorization. You must secure, if you are using event bus, you need to secure event bus access. There are more places to audit because you have distributed logs. And you must validate event authenticity, which means digital signatures. So, defense in depth is better to have choreography, centralized security, which tends to be easier. It's better to have orchestration. But if you go anywhere towards zero trust security, probably choreography is better. And then let's talk about changeability and coupling. If you're doing orchestration, the orchestrator is tightly coupled to the service interfaces. It can be tightly coupled to a service instance after calling it. If you add a new step, you need to change the orchestrator and add a new service. So changes in two places. Changing sequence requires orchestrator change, but changes are localized, visible, easy to understand. The orchestrator becomes an anti-pattern God service, and teams need to coordinate through orchestrator team. If you have a separate team for orchestrator and teams for each service, you need to wait for the orchestrator team to do its thing before you can actually implement the whole process update. If you are doing choreography with events, you have loose coupling because you have events. To add a new step, it's easy. You just add a new service that listens to those events. You don't have to change existing services when you do that. Services evolve independently. The coupling that you have coupling. The coupling is to the event schemas, and you never ever break the event schema. It's harder to understand downstream impact, and you can get to spaghetti events, which is a different way of doing spaghetti code, only with event-driven architecture. So, if you have a stable workflow, probably high coupling is easier. And you can pick orchestration because there will be fewer changes. If you have a rapidly evolving workflow, low coupling is critical, choreography is better. If you have multiple teams that need to work independently, then choreography allows you to be independent. But if you have a single team that just does releases, then orchestration is easier. And as you can see, this is yet another application of Conway's law. So if I were to conclude this, we could say when to choose orchestration, when we have a stable, well understood workflow, when we have requirements for strong consistency, the team needs to understand the flow easily, debugging, observability are critical. The team is not expert in event-driven systems. Few services involved in the business process. You could have multiple business processes, each with their own orchestrator and services. When to choose choreography? When workflow changes frequently and you have multiple teams, different release cycles, you need high scalability. The services are naturally independent, eventual consistency is acceptable. If you do event-driven, it can be a bit of mindset change. You need to think differently about the way you organize your code. So if you are just starting with events, it's better to start small. Many services can be involved, and if you need photo isolation, definitely choreography. Now, can you do hybrid approach? Of course, you could. You could have a large workflow, part of it using an orchestrator, part of it using choreography. Basically split it into sub workflows. Or you could have in a high level orchestration with choreograph sub processes. Yeah. Common anti-patterns to avoid. So try to avoid distributed monolith. So the situation when you have an orchestrator that knows a lot about the internals of each service. One way of doing this is by writing in the services databases directly. That's a very high coupling, so try to avoid that. Another anti-pattern, event soup. Try to avoid too many fine-grained events. You still want to understand the flow as much as possible. Mixing patterns without a clear goal. Be very careful because you get the worst of both. So it works if you are applying these techniques specifically to areas where it makes sense. And avoid over engineering. So don't use choreography for 3 services, especially when you know very little about events and when those services don't change that much. So as you can see, there are trade-offs for these decisions. One thing you need to take into account is you can always evolve from an orchestration to a choreography relatively easily. The other way around could be harder, particularly if you did the events, if you have a lot of events and it kept growing. But if you start with a central manager, that should be fairly easy to change to a distributed manager approach in the future. So this is what I wanted to talk about today. Orchestration versus choreography. I feel that this is not discussed enough as two variants for distributed workflows that are extremely common and where decisions should be taken based on the actual context of each application. And these are a few criteria, but you need to think within your specific context. So, in the end, do you have any questions about this? Let us know in the comments. Do you have any comments? Have you seen these patterns in your work? What other things did I miss? And would you like to add? Let us know in the comments. We always love comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.